Yeah, sit closer you may.
Don't look very.
Otherwise, I'm recording this for students who are absent, tardy, or who need to see it again. Maybe even students for next semester. Okay, so the first gas I'm going to make is oxygen gas. So what we did in class was use water and a battery to make oxygen gas. I'm going to make it faster. Actually, we did this already, but manganese dioxide and hydrogen peroxide makes oxygen a lot faster than water and a battery. It's actually salt water and a battery. So I've got soap bubbles to collect the gas. I've got a flask that already has some manganese dioxide, and then I'm just going to place the hydrogen peroxide in, and then it's going to make oxygen. Erwin, am I showing up in the camera? Okay. Okay, so let's go ahead and add, first let's make our soap water. I'm going to use distilled water so we have a more pure gas. And then I'll make another soap bath for the two gases when I combine them later. And then this will be hydrogen gas. All right, that should be plenty. If not, I can always add more water. It just won't be like a pure H2O. It'll be H2O with whatever's in our pipes and whatever's underground. All right, let's go ahead and stop that. Just add some if it's necessary. All right, let's go ahead and make some oxygen gas first. Peroxide. Maybe we'll add a little more manganese dioxide. I have it in a paper cup ready to go. All right, you see how there's bubbles? Those bubbles are the oxygen gas. When I place the cork on top, now the bubbles will release into this tube, and then when I put this tube in the water, we're going to get oxygen bubbles. How do we know it's oxygen? Well, what happened when we put a splint to the oxygen bubbles? It got what? It glowed brighter, right? We drew models on that. So I'm going to go ahead and put the oxygen gas bubbles into this aluminum. Let's put some more. It's more soapy than I thought. All right. So soap bubbles with oxygen gas. So if I zoom in, it would get a little bit brighter. It doesn't show as well as I wanted to. Now let's do the hydrogen gas.
Wait, that was it?
Yeah, that was it. Maybe it's easier if I show you right here.
Okay. Is that nature?
You see how the flames aren't going out? Let's do this. Let's make it into a glowing splint, and let's show how it gets brighter. Okay. All right, so I'm going to make this to a flame.
Flame it up.
And then I'm going to blow it out. So it's a glowing splint, and it should get brighter.
Oh. Too much fuel. Bro, you say that.
Okay, so here's our glowing splint. I'm going to put it in this oxygen.
Oh, here it is.
All right, did you guys see what happened? What happened?
I didn't even see it.
brighter.
It got brighter, okay? So normal bubbles won't do that. Normal bubbles will just put the flame out. Okay, now let's do our hydrogen gas, and then we'll combine them afterwards. So hydrogen gas is produced by a base called sodium hydroxide. and I'm going to add water to it and aluminum foil. And that's going to give a hydrogen gas. It's a lot faster than our battery and water. So I'm going to put the hydrogen, the sodium hydroxide, these little pellets. I'm going to put them inside of this flask. I don't want to drop them on the table in case my skin gets in contact with it.
Your skin is gonna burn if you get in contact?
It burns slowly, but this is all I'm putting in because I might have to do this twice for the combination of two gases.
I won't do that.
Okay, let's add the water and then we'll add the aluminum foil.
Which is the one that takes left off?
It's the combination of hydrogen and oxygen. Right now, I'm just showing you each one by itself. All right, let's go ahead and roll a tube of aluminum. And then we'll stick that into this hydrogen, sodium hydroxide, and water. Covered. It's already getting warm because of the reaction. If this is too slow, we'll use acid that I have in another cabinet. We'll let that dissolve. Let's see if we get some bubbles. Nothing yet. It all needs to dissolve first. Maybe I'll add some more hydrogen, sodium hydroxide. Let's add a little bit more. I do want my hands to stay dry, because if the water gets inside the jar, then it's going to make a harmful liquid to anyone's skin. And then we'll add some more water to make it dissolve faster. We'll keep this closed. See if it's working. It's working a little bit faster. Acids dissolve metals. Alright, you see how this liquid's getting like a milky white? That's the solution being produced. You just get these soap bubbles to form. We can light them, and the property of hydrogen gas, when you put a flame to it, what happens? It makes it pop. Everyone's screen's closed. Julian, close your screens.
Can I put the bottle?
It's actually not that hot. I do have a feeling that I am skipping a step of something.
Nice.
Because the it is dissolving. It's just so slow. Okay, let's add more water.
Maybe water's not helping it.
It has to be both the pellets and the water to make it speed up. Okay, it's definitely getting warmer now, which is a good sign. Let's test some of these small bubbles, and then we'll mix it with the oxygen gas to get a bigger reaction. All right. So I'm going to scoop some of these bubbles up.
That seems so fun.
Okay. Let's see if we get a pop. let's add more pellets and add more water. The bubbles are popping, they're not putting out the fire, which is a good sign. Brandon, you didn't really miss anything.
Oh, okay.
But you are about to see the stronger solution.
Can I go to the bathroom?
Yes, you may. All right, so that's about 3 tablespoons of pellets. That over there.
I see the bubbles for me.
This. Okay, we're getting more bubbles this time. I guess I could do the same thing that I did with, I just can't lift it as high. All right, let's light these. Okay, so did you guys hear a pop?
Yeah.
Okay, we'll do one more time. Okay, these are too little. So I gotta let them build up, and then we'll pop it again. But for now, let's go straight to the combination now. Okay, the combination of the 2 gases. So this is getting more efficient. It's actually getting very hot. And then this one has died down because all the manganese dioxide has dissolved with the hydrogen peroxide. So we're going to put more in, and then I'll do it maybe 3 times. So I guess the good part about this, how quiet everything is that so when it actually does happen, you'll start to see a bigger difference in it. Okay. So there's a lot of non-oxygen bubbles here. Scoop these out over here. All right. So closer. All right, and these are our hydrogen bubbles. I'm going to put these together with the oxygen bubbles. All right, so now I'm combining the bubbles. All right, combining the bubbles. Go ahead and close your screen. All right, let's go ahead and put these together. Okay, that's a little bit better. Let's get a better combination. Okay. You guys notice that? All right. What? Are your ears okay?
Yeah.
Ears okay? So what 2 gases did I put together? Alcohol? No. Oxygen and hydrogen. Oxygen and hydrogen. All right. Let's do it one more time. You can video this if you want.
Wait.
Sorry, I'm gonna be the camera. I'll get it.
Because you'll put too much. That's what will happen if you guys do it.
Get it on camera.
Oh, we gotta get this.
Bro, this is the wrong time.
Still have enough?
No, I got one of them.
Oh.
That's
What we'll do is
crazy.
we'll light the, we'll use a lighter to light this.
Okay. Y'all know y'all can do that? No, I be doing that.
If it's left-handed.
Okay.
All right. One more. We have enough for one more. One more.
Okay. This would do like 2 more. He said we only have.
I'll try to make it bigger, all right, so that you can get a louder bang out of the bubble popping. A little closer.
I already gave me 20.
Oxygen is slowing down. Okay, so this is about 2.5 times more.
2.5 times more.
Let's see if this will light. It won't.
Huh? Bro. Boom, 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 boom. Bro, you don't even understand. Exactly,
go.
like, bro.
Oh, okay, a lot of them popped. It is slowing down for both. This is making a lot of hydrogen gas. So ideally, we might want to have like a more stickier soap solution so that the bubbles get bigger. But this is pretty safe for the classroom where your ears won't get damaged. Yeah. Like there is a temptation to put the flame into this bucket, but the problem is the tubes are attached, and I don't want this hydrogen to explode with glass. And the same thing with the oxygen. But we can try this one more time. Let me see if I can make a little bowl so the soap doesn't keep spilling. Yeah, go ahead. Here we go. Let me see if I can shovel a whole bunch of soap bubbles. But it is slowing down. Yeah, these bubbles are getting smaller. But the key is you have to have both gases, right? If one by itself is not as impressive. Ready? All right. Let's all clap so the security knows it's not like a gunshot. All right. Okay, let's go ahead and let's try to explain what this all means. Let's explain what this all means. All right. So you can now open up your screens.
Can we do another hands-on?